Hello and welcome to the mining episode of the International Society of Explosive Engineers web series, Explosives Every Day, which looks at how explosives are used in a wide range of applications. I'm Alistair Torrance, President of the ISWE. Our organisation started in 1974 when a group of like-minded people got together in Pittsburgh, Pennsylvania to discuss how to better apply commercial explosives and how to champion the blaster in the field. Move forward to today and we're an international organisation with more than 4,000 members spread over 90 countries with a mission to advance the science and art of explosive engineering worldwide. We do this through sharing our knowledge and providing training and education for everyone involved with blasting. We also have a strong education foundation and have awarded more than $1 million in scholarships to our students in our industry. Before we get started, I'd like to thank our series partners, Dyno Nobel, OPIT Blast and LDE Global. This series would not have been possible without their tremendous support. This episode focuses on mining and how explosives are used to produce mined materials. Our mining sponsors are Austin Powder and Respec. Here's a little bit more about them.
Austin Powder is a leader in the manufacturing, distribution, and application of industrial explosives. Founded in 1833, today the company provides a broad range of highly engineered solutions. From bulk trucks to Red Devil underground units, emulsion technology to E-Star detonators, predictive vibration modeling software to optimize blast design. All Austin Powder solutions are developed to advance the safety, reliability, and efficiency of breaking rock.
As world-renowned experts in engineering, geology, information systems, and technology, Respec is a global leader in integrated solutions for mining, minerals, and energy. Respec's unique team of distinguished professionals offers mining and mineral clients the expertise to maximize profit returns while respecting the economic, social, and environmental well-being of a community. For 50 years, Respec has delivered adaptive solutions for the ever-changing marketplace. Their team's style of partnering as a trusted advisor creates a legacy of positive results and a strong rapport that is built on definable, repeatable processes and reliable, detailed communications.
This episode's presenters are Brad Brown of Dyno Nobel, Paul Sterk of Austin Powder, and Alan Dolan of Boliden Tara Mines. Brad Brown is a mining engineer with extensive experience in commercial explosives and blasting technology. He currently services the needs of the largest coal producers in the Powder River Basin for Dyno Consult. Brad will compare the early days of technology in the explosives industry to some of today's most advanced tools, while touching on how explosive engineers have needed to adapt through this technological shift. Paul Sterk has been in the explosive industry for nearly 50 years. He's currently semi-retired and working as an underground consultant for Austin Powder. As the Homestake mine came to a close in the early 2000s, a decision was made to blast the remaining explosives in the mine rather than send them back to the surface. Paul's story today is about one of those blasts. Alan Dolan graduated from Camborne School of Mines in 1997 with a Bachelor of Engineering in Mining Engineering. And he's worked as an explosive engineer for over 12 years. Alan will discuss precision blasting, pre-split drilling and blasting, close to finish walls. He also talks about 2 open pit mines with some information from a road extension. There's going to be a question and answer session with the presenters right after this presentations. The panel will discuss many questions that were asked by a live audience at the time of this episode's first airing.
I'm Brad Brown. I'm a senior consultant with Dyno Consult, a technical group of Dyno Nobel in North America. Dyno Consult does application training, product testing, field monitoring and measurement, and looks for solutions to mining and explosives application problems. My day-to-day activities with Dyno Consult, I help design blasts, I fly drones, I measure and predict vibrations, and explore product performance and blast outcomes. I also do blaster training and help with regulatory refreshers. I work in the Powder River Basin of Wyoming, where our surface mines produce a large portion of the nation's coal, and that accounts for about 11% of the nation's energy. A lot of our mining involves drilling and blasting overburden to extract the coal underneath. That means 9 to 12-inch holes, up to 225 foot deep, and loading as much as 10,000 pounds of explosives per hole. Mining around here uses 150 to 400 ton haul trucks, huge electric shovels, and drag lines to move material. Folks here say, we move dirt, mine coal, and load trains, and it all gets done with a great safety record. These are some videos courtesy of our joint venture partner Wesco. We're seeing a lot of cast blasting here, where we're using explosives, that is chemical energy, to move as much material as possible into the previous cut, into the previous hole. And after that, the mechanical equipment comes in and moves the rest to expose the coal. I've always said you have to break rock to get the value out. In general, mining is the extraction of a mineral that has a value at a time, at a place, and at a profit. Nothing is forever, and you have to make money doing it. And you have to restore things when you're done. In general, mining is about extracting minerals of value. Sometimes we're looking for coal. In other places it's gold, and it doesn't always fall out of the wall like this. We look for copper, iron ore, or diamonds. Sometimes the value is in developing subdivisions or building dams. Whatever the goal, we have to break rock to get the value out. And to do that, we use a wide range of explosives. These old quarry blasts show what we try to do every day. Execute planned, controlled blasts to yield, in this case, the aggregate and cement we use every day. In this example, explosives are loaded and timed to break the rock without throwing it over the edge or into a crushing plant. And most importantly, do it without hurting anyone or disturbing our neighbors. I said go places, and we do. Mining occurs all around the world, and these days mining companies are developing a global presence. One of the best things is going places, and it's good for a career. I started in Canada and have been in all the provinces except Nova Scotia, Newfoundland, and PEI. Been in a range of ores and materials, from copper, base metals, and iron, through to soft ground tunneling. There's some underground work in Northern Ontario, other places up in Tungsten, Northwest Territories, drove haul trucks on the north end of Vancouver Island in a copper mine, open pit coal mining, mountainous coal mining in Alberta, and many other places that I've been. Mining means asking questions as well. If you're looking at a career or already in the business, questions are a part of it. It's a great place to develop and use a wide range of skills, and while it's an old profession in some ways, it demands and uses some of the newest tools. My sons played Minecraft, where they developed underground structures. Heavy trucking and earth moving is what's driving GPS development these days, and computer modeling is a key part of mining and also explosives use. And I've said, if you're looking for a job, always ask if there are other roles. If you've got a job in the business somewhere, get some help detailing or redirecting your efforts and what you're focused on. And if you're trying to change your job, ask if there are other ways to do this. There's always a new way to break some rock. Embracing technology is a key part of the mining business, I find. There are lots of challenges in mining, and a lot of people want to try new things. Mine design blends geometry, scheduling, and finance But also thinking and using new tools on the bench can save a lot of the sweat and work using your back to accomplish things. It's come a long way from picks and shovels or sticking dynamite in a hole. I said I've gone places. I moved back to the US and I'm in Wyoming now, where we do the coal mining, but I've also been in all but 4 states within the US and lived in a variety of places, and I've gone way more than that. Open pit gold mines in the Southwest and elsewhere, civil works like the Hoover Dam, the new bypass road, some underground operations in a variety of materials, quarrying operations where they're making aggregate, cement, asphalt, and a range of other products for people, for society. The largest users I mentioned of explosives are here in the Powder River Basin. Mining coal is my current focus. Here's a shot of a dragline exposing the last strip of coal in a pit before they move on to the next part of the operation. But after the explosives job is done, mining also includes reclaiming the land, reestablishing the original plant species, and restoring the water courses. Sometimes you see odd things out in the mining world, but mining is breaking rock and moving materials, and explosives are a big part of that. And as I said, it's also returning land to its original use. Sometimes we even get to blast to reshape the final ground contours and bring back native species of all sorts. Things that you can look for in the mining world. For me, in the explosives side, I look for a leader in safety, products, and technology. We need mining to supply our world, and explosives are a key part of mining. Both demand safety and technology in the tools and products we use, whether it's the equipment to deliver products and load it, or technology to set off the explosives and make things happen. And sometimes we just have some fun.
Hi, my name is Alan Dolan and I work as a project engineer in Boliden Tara Mines, Navan, Ireland. The mine is located about 1 hour west of Dublin and is the largest underground zinc mine in Europe. Production in Tara began in 1977. The life of the mine has recently been extended with the discovery of a satellite deposit, Tara Deep. In November 2020, the exploration decline being excavated towards this deposit has reached 1.6 of the planned 2.1 kilometres.
When I chose a career, I wanted one where I could travel, work indoors and work outdoors. And I certainly got that when I chose mining. Between 2008 and 2009, I worked as the explosives supervisor on the NBFO2 Newry bypass upgrade in Northern Ireland. Over 10,000 square metres of pre-split was blasted during this project. So, how was it done? To ensure drilling was accurate, surveyors marked colour, direction and depth of each hole. We assembled the charges on site as they were required. There was a lot of infrastructure close by, so fly rock, MIC and overpressure and noise were major factors. After loading and before connecting the holes, a mocap was inserted into the hole, followed by stemming. This helped minimise noise, overpressure and fly rock. This is how we assembled the pre-split. 12-gram cord was run along the spine of a plastic trim clip. Explosive charges were inserted on the trim clip at even spacings. We used plenty of electrical tape to ensure the cartridges did not move. This photograph shows the cartridges ready to load. The trim clip was rigid enough that it did not need to be suspended inside the hole. These photos are of some of the first charges we used on site. They worked, but as with any large blasting project, the design and methodology was refined as we progressed. And the final result, 12 years later, still looking good. In 2010, I worked with a mining contractor in West Africa. I alternated as the drill and blast supervisor in the Syama mine in Mali and the drill and blast manager at the Yuga mine in Burkina Faso. The journey to Siama began with a flight from Dublin to Paris, then Paris to the capital of Mali, Bamako, and finally a 4-hour drive to the mine site. The Siama gold mine was located beside the village of Forou and approximately 30 kilometers from the Côte d'Ivoire border and 300 kilometers southeast of Bamako. So, a quick overview of mining in the Siama pit. The ore is in the western side of the pit, and to the eastern side are less competent shales. The main production blasting was done with the Atlas Copco drills, and the ancillary drilling was done using the Atlas Copco F9 and Sandvik Pantheras. When the rock was blasted, it was excavated in flitches or in slices to minimise dilution. Paddock blasting was the main type of production blast in Siama. Firing large quantities of explosives in tight patterns can have a negative effect on the integrity of finished excavations and pit walls. To minimise this damage, a crack was created by pre-split blasting. Unlike the charges we saw earlier, the explosives were tied directly to the cord and suspended inside the hole. Having fired the pre-split, the trim shot was fired. This is a typical trim shot design close to a pillar or a final wall. As you can see, the holes are drilled differently and charged differently to minimise the effect on the final profile. So how successful was the pre-splitting in Siama gold mine? It worked well in the competent rock to the west, with varying results in the poor geology of the contacts at the east wall. So, if your holes are too short to pre-split, trim or stitch drilling can be as effective. There are no issues with vibration, overpressure or fly rock. Hole spacing should be as close as possible, and for accuracy, surveyors should mark the colours on the toe. There are many reasons not to overcharge development round underground. The most important is to reduce or eliminate the blast damage zone around an excavation. For example, if a pillar between two tunnels has been designed to specific dimensions and failure criteria, any damage or overbreak will compromise this design and ultimately the load capacity of the pillar. This is an example of a round used in Boliden Tara Mines. The outer contour holes are string loaded. The inner contour holes receive a reduced charge. All other holes receive a full charge with varying colours. And finally, a short animation which shows string loading using the Orica Avatel system.
Good evening, good morning, good afternoon, wherever you are in the world. Welcome to the first presentation for the young professionals. This evening will be on mining. My topic tonight will be blasting can be fun. It was a project we did at the Homestake mine in 2001 at the very end of the year. The Homestake mine is located in South Dakota in the western region in the Black Hills. As you can see, the mine ran from 1876 to 2002, and there really is gold at the end of the rainbow. The mine itself is a very large mine. It goes from the surface all the way to the 8,000. There were levels were 100 feet apart down to the 1,100, and from there they're 150 feet apart, all the way down to the bottom, which is the 8,000. We had the sump was at 82, and we had a ramp going down, but we stopped at the 81. There was a ramp in the mine. We put ramps in as we went trackless. You could go from the 48, all the way from the 8,000 to almost to the 26 on the ramp. It was a huge ramp system. Also, the temperature varied in the mine, which had a lot to do with we did a lot of beta testing with explosives for companies, because our temperatures ran from around 33 to 40, 34 to 33 to 40, 34 degrees in the upper part of the mine, down to the 8,000, which is at 133 degrees. There are over 400 and some miles of tunnels here and trackless ramps. This is a general cross-section of the mine. It's very simplified. It's about 3.5 miles from the mill to the number 5 air shaft. You can see the different shafts in between, the Ross and the Yates being the main ones. And very deep mine, very wide mine. It goes into the paper and into the slide, out of the slide, thousands of feet also. So very, very large mine. As the mine got ready to close down in 2001, people started leaving messages, and this is one of them here. It says, Pete says goodbye. And this was done by a guy named Woody, who was a really good artist. In fact, the mine hired him to become he did our safety manuals and stuff. He was a very good artist, and there was a lot of these around the mine. Here's a place by a doghouse, an office underground. We call them dog houses. You see there's a bunch of different things on there. Like it was interesting to see what people thought. And like HMC on there we always thought it stood for Homestake Mining Company, but as you can see, it says hire more Canadians. So this was in the late 2001. They tied in the final blast at the mine. And at that point, there was going to be no more production blasting going in the mine. This is a long hole stope here you're seeing, with dual delays being tied in. So here's a typical powder magazine. This powder magazine, you'll see these, we had these all over the mine. They look like this after we went trackless. We used to have rail everywhere, and we had to unload cars now. We went trackless. And there's actually some concrete barriers in front of this you don't see too. And but none of the magazines were locked, because we were attended by the new law 24 hours a day by a hoist, so we didn't have to lock our magazines, which made it really easy to get in and out with forklifts. So here's a typical CAP magazine, or detonator magazine, for the mine. You can see all the different types of detonators we had to carry, from LPs to MSs to long delays to just everything, to dual delays, and we did. So there's a lot of these left over. So in the mine, in the end, the decision was made to blast all the remaining explosives. The reason for this was it was cheaper to blast the explosives rather than hoist them and pay a restocking fee with the explosive supplier. Our hoist was very expensive to run, and most of the explosives would have to pass through 2 shafts before they reached the surface. This hoist time was needed to salvage equipment like drills and loaders and fans and many other things related to the operation. So all this hoist time was needed very much in the end, because the last thing they were going to do is pull the transformers on the 8,000 and let the mine flood. And the mine did flood. Eventually, it went from all the way up to around the 4,700 with water over the years. Now it's been pumped back down to some extent, because a lot of you know this is now a major physics lab. So anyway, the explosives were consolidated from the last magazines in the area to an area where they could be blasted. In preparation for the blast, thousands of feet of ventilation bag were taken down, and we also got as many fans out of the area as we could, and we shipped them to the surface, and the ones that remained we chained down. It's just a typical vent tubing in an underground mine. This is a generic picture right there. And then this is one of our coolers underground. This was a 10-ton cooler. And we shipped, like I said, we shipped all these out, and the ones we couldn't get out, we chained down. So here's a picture of the crew. They're tying in all the extra detonators. All the detonators we had left, we shot in one shot. And they're being hooked up. And it's like a supplier's dream to see all this stuff basically being wasted, but we actually save money by doing it. This is one of my favorite pictures. He's almost done. You can see just detonators everywhere. And what you don't see here is there's also boxes of boosters and cases of powder behind that we wired all this into that to make sure everything went off. So they pushed the button and kaboom, it went off, and it went off big time. Bigger than we thought, in fact. It made a lot more wind than we thought. Here's a picture of one of those offices where the bosses were at. And as you can see, it knocked the fan off down onto the ground, the clock off the wall, paper everywhere, and pretty much made a mess. And this is a picture of an air door that got blown off of a fuel dump. The fuel tank had been removed, but the air blast took the door down, so you can see it made a lot of wind. This is another picture of just the destruction. So that was a really quick thought on a project of mine. We don't have a lot of time, each of us, tonight, but I'd like to do a conclusion and thoughts to ponder for young professionals. And sometimes blasting can be fun, like is in this picture. This project was. And as a new professional, you got to love what you do every day. If you don't, you need to find something else. Think out of the box. I know this is pretty much a cliche term or whatever, but anything is possible. One time we had a blast in the mine where we had to shoot a raise, a blind raise, and a slot, and a whole stope of rings, and we didn't have enough delays. So we sat around long enough, me and another guy, and we figured out we could use a sequential machine, except we didn't have one. So we built a sequential machine with nails and a board, and used electric caps to set off the detonating cord. And we were able to set off each section of the mine in a certain sequence, and it worked. So you can do things. You just got to think all the time. Anything's possible. And learn from your mistakes. You're going to make mistakes. All of us do. Don't be afraid to make them, because then when you do, you're going to learn. You're never going to learn if you don't make mistakes. And anybody that says they don't make a mistake, it's not true. And above all, remember that explosives are the first primary crusher in the mining cycle. And that's in any mine, surface, underground, or whatever. And also that you want to go home every day with all your employees and the people around you and your customers and everybody you work with safe to go home every day. Remember, it's explosives, and explosives are made to go off, so you have to be careful.
Our question and answer session with moderator Travis David Saver, ISWE board member and emerging professional section chairperson, begins now. So take it away, Travis.
Well, I'm Travis David Saver, and I'll be serving as your moderator this evening. And first of all, I'd like to thank our sponsors for their financial support. Without them, we would not have been able to bring this free series to all of you online. Let's talk live with our panelists. Right now, Brad is coming to us from Wyoming. Paul is in Ohio, and Alan is in Ireland, where it's very early in the morning. They're all ready to answer your questions. So please send any of your questions via the question and answer box, and we'll be sure to pass them on to our panelists. Our first question is for Brad. Brad, besides being a mining engineer, what other educational disciplines lend themselves to becoming an explosives expert?
Good one. I've seen a range of disciplines. The ones that jump right out, obviously, are chemistry or chemical engineering, physics and geology, or geological engineering. But I've also seen a number of people come in from the sides, if you will, very different backgrounds. Just the ability to ask good questions tends to work well in the business. An example of that, John Floyd is somebody I've had some respect for a long time. John's a consultant out of Steamboat, and he was out surveying, doesn't really have the background in any of these disciplines, but he's done very well at asking and answering questions. So the engineering disciplines work, but just a good inquisitive nature and some common sense goes a long way too.
All right, thanks, Brad. Alan, what happens if pre-shearing doesn't work properly?
Well, really the whole point of the pre-shearing is to make sure that it does work properly, to make sure you have a finished face. But I suppose in I've worked in three aspects when it comes to blasting. One has been open pit mining. In general, an open pit mine is big enough that maybe you can avoid a part of the hanging wall that hasn't pre-sheared very well. Maybe you can avoid it. Generally, what you'll do is you clean it up and monitor it using LIDAR or something like that. If you see any movement, maybe you'll do something else. In the case of civil engineering work, something like a road job, well, that's going to be there for a long, long time, heavy traffic, cars, pedestrians, whatever. So you may need to do some remedial work on that. You may need to re-support that area. You may need to shotcrete it, put in some cable bolts or ground anchors or something like that to make sure it stays there, because you're dealing, it's a public throughway. And generally in underground mining, if you have, for example, what I showed in my presentation, a pillar that is designed a particular way, if after blasting it's affected, you're going to either have to fix it up, if you can at all possibly fix it up, strengthen it with some metal, with some shotcrete, or you may have to redesign the excavations around it to try and avoid that particular area, and maybe make the ones close by a little bit bigger, a little bit stronger.
Okay, thanks, Alan. Our next question here is for Paul. Paul, handling explosives sounds dangerous. How do you keep yourself and everyone around you safe while you're handling those explosives?
Well, first off, these days, explosives are a lot safer than they were back from the dynamite and black powder days. We've come a long way. But all the time, it's continuous training. You need to train your people, make people aware around you what you're doing. But training. You cannot do enough training. So,
Brad and Alan, do you have any other thoughts on how to keep everyone else safe?
Sure, I'll jump in there. One of the things that that I've done with Paul is our Best in the West Drill and Blast conference, and part of the goal there is to give annual training hours to a lot of the miners, to the blasters, because they're required to get additional training. They are required to do that to keep a blasting license. So we push to do that, and in the COVID environment, we've done some online webinars with, for example, the Wyoming DEQ to get blasters the training that they need to keep current, to keep certified to blast.
All right.
Yeah, if I can just add to that, Travis, because the audience we have here are young engineers, junior engineers starting off, my advice would be to stand beside the likes of Paul and somebody like that, and you keep your eyes and ears open and just watch what he does and listen to his advice. Training is great. Reading things out of a book is fantastic, but there's nothing like asking somebody like Paul or Brad who've been at this for a long, long time, ask their opinion, and you pay attention to what they say, because I can guarantee you in a couple of years' time, you'll think back on what that guy told you and it'll be the right thing.
Well, I can say firsthand, Alan, that I had an opportunity to go down to 8,000 feet in the Homestake mine with Paul 2 weeks before they stopped mining. And I learned more in that 10 minutes of being down at the 8,000 foot level than I ever could have read about in a book. So I can't agree with it. The next question here is for Paul. How many blasting caps did you have tied in together in that picture for the disposal of those explosives?
we had over 3,000 tied in. So it's pretty interesting sound when it went off, for sure.
And Paul, were you guys all underground when you shot it?
Oh yeah.
How far away were you?
About 2,500 feet. So we were a long ways away.
All right. Our next question for everyone comes from Margaret Dotto. How can you control fragmentation in variable rock mass?
Boy, everybody wants to stay away from that one. Tough one. What I've learned from Paul and what I learned from Alan and a number of others, you've got to distribute the energy appropriately for the rock. And if it's going to vary on you, your best guess is going to be tough.
Yeah, and I'll just to add what Brad has said, yeah, you need to pay attention when the guy is, if you can at all, talk to the driller, get a driller's log, ask them to write down what they're actually drilling. It depends on your machinery. Some of the machinery is automatic. It'll do it automatically. It'll drill through soft or hard parts and it'll be collected in the database. But some of the machines are older machines. And if you can speak to a driller who knows his job very well, and before you even approach him, he'll tell you, he'll say, listen, I've got a bit of a problem here. And as you drill your pattern, you can maybe vary it a little bit, maybe change the density of the explosive, maybe change the timing a little bit. Fragmentation is a dark art, and anybody that gives you a concise answer on that, I'll shake their hand.
we have exactly that problem here in very soft ground. We can drill for a large pattern and move the material. Fragmentation for the soft stuff is not difficult. But if you're going through a hard layer of sandstone or you have floaters, boulders in the material, getting them to break properly is tough. And it's not uncommon for us to see a D11 dozer pushing large chunks or stuff that just cannot be broken with a large, widely distributed explosive charge.
Yeah, I like to say the same thing, that distribute the explosives and pay attention to your geology. It changes all the time, you know, even in the Homestake mine from the bottom to the top. And when we were doing some new exploration, we hit some X rock. We'd never seen it before, and we would shoot it around and muck it out. And the next shift would come in, and the muck pile was there again. And what was happening was the rock was expanding. It was a type of expansion rock. They got a new name for it at the South Dakota School of Mines, but it was a geology we'd never seen anything like it before. So it was you got to learn all about your geology. Pay attention all the time.
Yep.
All right, the next question here is again for all of our panelists, and you can each answer with the question being, which is the one book that every explosives engineer should always carry with him or her?
ISEE handbook.
I was just going to say your notebook.
Yeah, and your notebook. Okay.
Correct.
Yeah.
And you write down what Paul and Brad tell you, and you pay attention to what you've just written down.
I would go with the two, the notebook, because you're supposed to be listening. One of the things I wrote down earlier today was 2 ears, 1 mouth. You want to be listening to what people have to say. The other one is the Explosive Engineer's Handbook. Those have been developed over a long period of time, and there's a lot of stuff in there.
All right. Our next question is for Brad. You mentioned 12-inch holes loaded with 10,000 pounds of explosives. How deep was that, though? How deep were those holes, and how many boosters were needed per hole to get that explosive to go?
10,000 pounds, how deep? For a 12 1/4 hole, we typically load at about 68, call it 70 pounds a foot. So you could probably get 10,000 pounds into a 180-foot hole. Remember, you're not going to load the top 30 to 40 feet, and best practice would have you use at least 2 boosters in there. We've been doing some work with more than that, depending on our application.
And Brad, can you remind us why we need boosters in that type of an explosive product?
Well, the explosive is all geared to a chain of controlled energy, from the Wile E. Coyote rack bar machine to energize something, or a shot shell primer to shoot shock tube, or the electronic system to send a digital encoded message to an electronic detonator. You set off a detonator that then shoots a cast booster, which amplifies the signal, and that gives the big kick to make a bulk explosive that is relatively insensitive, gives it the big kick to make it go off. So every time you put a booster or a primer in there, that is a primer being a detonator and a booster together, you get that signal and that amplification to fire that bulk explosive.
All right. Our next question here is for Alan. I've heard about pre-split blasting with det cord and smooth blasting using string loading. What is the panel's opinion on the safety aspect of using det cord for smooth blasting regarding the risk of cord left in the muck pile due to cutoffs and misfires, and the effectiveness of string loading?
Yeah, there is an inherent danger there using cord to pre-split underground. When you fire, if it doesn't fire, you could have cord in the muck pile, and as we know, it can detonate through impact. That is definitely a hazard. We use string loading in Boliden Tara Mines. And of course, and this will recur over and over again, it depends on the geology. It depends on what you're trying to hit and what you're hitting it with. In general, our contour blasting works very well with string loading, but it is very geologically dependent. If you've got good, competent, strong rock, 120 MPa, you'll have a good result. But if you've got shales, if you've got joints, if you've got a lot of geology, the result can be variable. And you can have issues loading those holes as well. As regards using it on surface, anytime I've used cord on surface, I would have used it with the cartridge product, and you'd fire it in the open cast mines. You'd fire it using the det cord as a trunk line and down the hole. In my presentation, I showed firing using non-L because it was so close to structures. But in general, for the open cast mine, anytime I've used the cord, it will all detonate, and generally you don't end up with an issue in the muck pile.
All right, our next question here is for Brad. And what's the largest blast you've ever been involved with?
Largest blast, 2.1 million pounds, 1st of May, 2012. That was a 2,100 foot long cast blast. That was impressive.
Right. How about you, Paul? What's the largest blast you've been involved with?
Largest blast underground we did was about 120,000 pounds.
In one shot?
In one shot, yeah. And that's in the old days. We had to hand pack every bag of explosive in there and all of our stemming and everything. It was a very long project.
All right, we've got quite a few questions that are still coming in from folks. We'll try to get through them as quickly as we can. Alan, what's the largest diameter borehole you've ever seen used in pre-split or trim blasting?
Oh. Generally about 105 mil. If you go too big, you're going to need a charge to actually fill for the gases and the impact to break the rock in between the pre-split holes. You get, well, from my experience, I've never gone much bigger than 100 and 105 mil.
Wow. The next question is from Jessica Rosas Pelaez, who's asking about young professionals in the explosives mining jobs. Is it complicated to jump between oil and gas and mining, or vice versa? Do you see any challenges with jumping with that experience between oil and gas and mining?
I'm afraid I don't have any experience in oil and gas, guys, so you'll excuse me on that one.
My only guess is out here, we do a lot of oil and gas production in Wyoming. There's very different explosives used there, so you're not necessarily going to get the experience with the explosives, but the ability to assess situations, to work safely, to work with people, to find out how things could be done better, to ask good questions and take on tasks. All those attributes tend to work well. Maybe one of the things we say out here in a lot of the mines is they have very good training abilities. They're looking to hire attitudes. So if you've got a good attitude and you can work well in the oil and gas business, you can slide into the mining business.
All right, our next question here, I think, is for everyone as well, from Frederick. How do you explain to someone that explosives are inherently safe?
Good one. I like us from the, I'm sorry to jump in, I like this one from the detonator side of the business. We went with electronic detonator, and the answer is the evolution is making things safer and safer all the way along. We've started with electric detonators, and they were susceptible to static electricity discharge, and you had to get the right energy in to make them go off properly. You had to do series calculations, balance series, worry about resistance, and so on. We got into shock tube detonators because they were immune to static and things like that, and you didn't have to do calculations, and people went, woohoo, no calculations. You still had to work out timing. Then we got into the electronic detonators, and it got rid of a lot of the issues, some of the limitations there, and you get coded signals that are very hard to duplicate, so it's very much more difficult to accidentally set the things off. So as a product evolves, you can eliminate some of the hazards and things along the way. I'm sure it fits in the powder side there, Paul.
Yeah, I agree with you on the powder too. We've come, like I said, from black powder to dynamite to water gels, and then we've evolved into emulsions, and now we're into gassed emulsions, and where a lot of products are manufactured right on the shot versus before, you know. And I think it's made a big difference. I agree with you on the electronics, though. The electronics have done a wonder for this business.
All right, and that's about all the time we have left here for this question and answer session. We had a lot of additional questions that came in. Unfortunately, we just don't have time to get to them. I really want to thank everybody on here for attending the first part of tonight's session regarding mining and how we use explosives in mining. And I really want to say thanks to all of you for your great questions, and a special thanks to Brad and Alan and Paul for their time in helping put this together and being panelists to talk about explosives in mining.
So thanks Travis, and thank you for watching this episode of the ISEE Explosives Everyday series. Explosives are the ultimate power tool that help mine the minerals and materials that are used in creating many of the products and roadways we use each and every day. They help keep our towns and cities safe from avalanches. They are used to shape and improve the environment, and also military and demolition applications. And they're in some of our favourite TV shows, movies, sporting events and concerts. Our job as professionals in the explosive industry and at the ISEE is to ensure explosives continue to be handled and applied in the safest way possible, and to continue to provide the resources and tools needed to help advance the science and art of explosive engineering. If you're interested in finding out more about the International Society of Explosive Engineers, please go to our website, isee.org. You'll find information about membership, our chapters around the world, and other useful links, including a calendar of upcoming events, as well as conferences and meetings in our industry. Another great resource is the World of Explosives, where you can find information on using explosives safely, the most frequently asked questions from homeowners about blasting, how blast vibrations affect structures, and all the planning that goes into each blast. It's also home to Explosives the Power Tool. This is a video series covering the history of explosives and the technical advancements that have been made possible because of them. To check it out, visit explosives.org. So once again, a special thank you to this episode's sponsors: LDE Global, Dyno Nobel, OPIT Blast, Austin Powder, Respec and DNA Blast Group, and to all our sponsors throughout this series. Before we go, here are a few short words from one of our series partners, LDE Global.
The ownership group of LDE Global has been developing, patenting and supplying explosives internationally for 50 years. In 1999, following invitations and support from international mining groups, LDE entered the North American explosives market with a range of low-density, low-shock explosives known as hybrid explosives. These are ideally suited for the huge variation of rock types and mining methods across the United States. As a completely independent supplier of explosive products, technologies, equipment and consulting services, we'd like to say thank you for watching, and feel free to call us at any time.
So that's it for this episode of Explosives Every Day. If you like this content, be sure to like and subscribe to our YouTube, Facebook and LinkedIn pages to stay up to date with all the latest ISE happenings. And be sure to check out all 10 of our episodes highlighting the different ways explosives are used around the world every day. On behalf of the ISWE, thanks for watching, and we'll see you next time.